Hey everyone, this is Derek, and this is going to be a little refresher on solving quadratic equations. I'll do a couple examples by factoring, and then a couple examples by quadratic formula. So let me introduce the quadratic formula, and I'm guessing most people have seen this, but let me just kind of do a little brief recap in case it's been a while. So if I have a quadratic in standard form, I can solve that by taking the coefficients and plugging them in the formula. Where this formula comes from is if I solve this over here for x, I get this. And instead of doing that every time, what we did was said, hey, we're just going to call the formula. So every time you have something in this form, this is the answer. What this is it's giving us the intercepts, or the places generally we're setting. Hi. Sorry, my cat just interrupted. So what it's doing is it's giving us the intercepts because this over here was set equal to 0. And so we can see we would have three possible things that could happen with a parabola, which is what x squared is a parabola in terms of the intercepts. The parabola could be above the axis, or also, it could also open below the axis, and I'd have no solutions. If it comes down and just touches and bounces off, I could have a situation with one solution. I could also do that from this direction. Or I could make it cross twice, like in this one, and those are my two solutions. So when we're solving the quadratic and we get no solutions, this is what it means. When we get one solution, this is what it means. When we get two solutions, that's what it means. The reason that happens is because of the root. So here we're going negative b plus or minus this chunk of math. And this chunk of math is under a square root. Chunk of math is called the discriminant, by the way. And so if this chunk of math is negative, then it would be an imaginary number, and I have this situation. If this chunk of math is 0, then what I have is negative b over 2a, and I have that point right there. If this chunk of math is positive, then I have plus or minus two different values, and that's the situation where we're getting two different intercepts. So that's kind of the geometry behind what the quadratic formula actually is. So now let me solve a few problems from a couple of different methods. First off, if something factors easily, if a quadratic factors easily, just factor it. Like the quadratic formula is sort of the 10-pound sledgehammer that will pretty much do any job, but sometimes it's overkill. So in this one, are there two numbers that multiply to negative 30 and add to be negative 7 that you can figure out pretty easily? Yeah, it's going to go x minus 10 and x plus 3. Because that multiplies to be the negative 30, and then negative 10 plus 3, there's our negative 7. Setting this to 0 is what we do, and we bring the 10 over, and that's why the zeros and the factors have opposite signs. So my 0 is going to be at x equals 10 from the factor x minus 10. Likewise, this would be at x equals negative 3. So that would be the place, if we're looking at a graph, where we'd be crossing the x-axis. This one, difference of squares. This is an a squared minus b squared equals 0. And remember, these kind of always factored a plus b, a minus b. So definitely not worth shoving that in the quadratic formula. If you did, b would be 0. That would be the trick to that one. Easier, though, is to just go 2x plus 1 and 2x minus 1 equals 0. And then I wanted to do this one so I could remind you how to solve this little piece. It's actually super easy. You just have to remember what you're really doing is setting each of these to 0. You're just bringing the 1 over and then dividing out the 2. Same thing, 2x equals positive 1 this time, and then divide the 2. So that's how you solve those when they have a coefficient. So this one actually does factor, and so if you're great at factoring, cool, you can do 6 times negative 3 is negative 18, realize you can make that come out to a positive 7, and either do AC or magic method. In reality, from my experience, like probably in a class of 30 people, maybe one person can actually factor that. So we have the quadratic formula, we can use it, it works every time. This is probably, especially in a business course, not a bad place to just bust out the quadratic formula. So let me copy that down right here. But yeah, so even though this does factor, that you can also just get there this way. Another thing is a lot of times in the application problems in this course, while they would have factored, the numbers can be really big, and so the factoring isn't the easiest thing, and I would just stuff it in the quadratic in that case too. So good argument for the quadratic formula. So putting, this is going to be our A is 6, our B is going to be 7, and our C is going to be -3. We got to be careful to catch the signs. So this will go x equals -7, and then plus or minus 7 squared minus 4 times A was 6, and C was -3, all over 2A, so 2 times 6. And then let's clean that up a little bit. So that's 49. 24 times 3 is 72. And we're adding those all over 12. And we're adding those. So up here, I just count the signs. I don't think, okay, that's negative, and the negative times negative makes positive. I'm like, 2 negatives is going to be positive. And I come down and write the plus. If I had 3 or 1 negatives, I just come down and write the minus and then not overthink it. X here, -7 plus or minus. That is 121 over 12. So that's going to be x equals -7 plus or minus. Square root of 121 is 11 over 12. And when those come out nice like that, that means they would have factored. But again, if you're not great at factoring, you can just do this. I'm going to come up here. And then here's where people get a little mixed up, is that plus minus. So what that means is we have 2 answers, right? Because back here we have these 2 distinct answers. That's what this plus or minus is giving us. So this is actually representing 2 completely separate solutions. -7 plus 11 over 12, and it's also -7 minus 11 over 12. So here, this one would be 4 over 12, also known as 1/3. And then this one would be -7 minus 11 is -18 over 12. So that would be -3/2. So those are our 2 solutions. Okay, for this example, it's not quite in standard form. So whether you rewrite it or just sort of acknowledge that that should be a -6, either way, that's fine. I will rewrite it, set it to 0, and then there's my A, my B, and my C. So I'm just going to put those in the quadratic now. X equals negative of -3. And feel free to write just +3. I'm just showing my steps here. Here, be a little careful. I'll see people write that. That's not right. That means -9. And if you put it in the calculator that way, it'll tell you it's -9. You're really doing this, and so that value should always be a positive. So a lot of times, like if I'm doing it for me, I don't even write that sign because I know it's going to be a positive number, but careful not to type that in the calculator wrong. And then -4 times A was 2, and C is -6, all over 2 times 2. So cleaning this up, minus and minus is plus. And again, feel free to just jump right to there with it. This would be a +9, minus and minus, that's going to get us a plus there. 8 times 6 is 48 over 4. So here, x equals 3 plus or minus 1757 over 4. And with this one, that's as far as I can go. That square root 57, that's some ugly decimal, so I'd have 3 plus the decimal divided by 4 would be my first decimal, and then 3 minus that would be my second decimal. I believe for the problem on the computer that I have this tied to, it wants the exact form. Usually the computer will want the exact form if it's just a straight up math problem like that. So you would just type this in. Careful, I think the form it wants the answer is this. And then the second part is, the second answer is this. And so a lot of times people will try to get that set up in the box, but it's 2 distinct answers. The same way if there's an answer box, and let's say your answers were X were 7 and 3, you would type 7 and 3. This is what you're typing in that answer box.